Hey everybody, welcome back. Today we're going to be talking about the cloud and kind of what it is at a very high level. Now, this is cloud applications development, so I'm going to assume that you have at least some idea of what the cloud is, whether you've heard about it, whether you've played around with it in the past, but obviously our focus is more on developing apps for the cloud. So what we're going to talk about today is kind of introduce you to the main concepts of cloud computing. And if you want a very, very good overview, I've linked a video to a Google intern presentation. It's about 40 minutes long, so feel free to put it on in the background and listen to it. It's a very, very good overview of all the things that basically Google Cloud has, but honestly, the concepts apply to pretty much any cloud provider, honestly. But what we're going to be going over today are kind of some of the highlights of what cloud computing really are in comparison to like normal services that you would have from an IT infrastructure perspective. Now, just as a little aside, some of the slides that I'll be using and some of the content that I'll be using for this class are provided by Google. They came up with a cloud computing course. I'll be modifying it for our purposes. But if you see slides that look like this or content that looks like this, that's where it came from, basically. Um, and there's going to be a little modification that I modified this content disclaimer all over the place because it's tailored for you all. But at its core, cloud computing, the buzzword kind of takeaway is it is somebody else's resource, basically. So using somebody else's server. It's the very, very, very minimal way of describing it. But there is a ton of concepts with cloud computing. So here we've got five on the screen that you see here. We have on-demand service, we have broad network access, resource pooling, elasticity, and measured service. So what the first one is basically that on-demand self-service, it is always on. You can get resources as you need them, and it is self-serving. So basically you log into an interface of some kind, whether it's a web console, whether it's an API call, but you are in charge of getting the resources. You don't have to say, put in a ticket to IT to get a virtual machine provisioned. It's just ready to be set up there all by yourself. So it's kind of nice in that you don't have to, rely on a massive IT infrastructure to get resources. You can just do it directly. You pay for it, obviously, but um, it's there for you. The second key takeaway is that it is accessible anywhere you have a network connection. Now, with cloud computing, the concept is basically that everything is networked, right? Everything is accessible. So you do need that network connection. However, you can access it from anywhere. Right? Let's say you're a cloud apps developer. Let's say you're a sysadmin, whatever your role is, it doesn't matter. You could do your job just as easily from the office as you could sitting at home, as you could from vacation. If a fire in the data center happens, you have to change things over. Basically, it's network accessible from anywhere. You don't have to worry about VPNing into your company's infrastructure. It's all just in your cloud provider for good and for bad because it is on somebody else's servers, right? The third one here is resource pooling. Now, this is kind of one of the neat little behind the scenes features that you get with cloud computing. There is effectively a massive pool of resources available for all customers, right? Not just you, for everybody. Consider what you may have heard about Google and Amazon's data centers, where they are now, data lakes, not data centers. They are the size of multiple football fields, for instance. All of these resources are available for everybody who is a customer. And what that means is that you can access this massive pool of resources simply by being a part of the ecosystem. And that means that you can use as much or as little as possible, right? You don't need terabytes upon terabytes of RAM just to run a basic compute engine job, for instance. Or if you're running a massive load balanced web server, you can get access to more resources. It's just available for you there. And with this resource pooling comes the notion of geographic location, which is another really nice benefit of cloud computing. Basically, here you can set up your service to be geolocated to wherever it needs to be. So let's say that you are a multinational company, right? You're serving clients in multiple countries. and you're going to set up a web portal for all of them. You might have a localized web portal in San Francisco, in Michigan, in Europe, in Asia. I'm saying cities and countries now, but basically you can geographically distribute your access points as you need, and then your customers see a very quick response time. You could extend that by, say, load balancing, right? All of your clients in California are just hammering your server, and the website slows down or it goes down. Well, you can load balance over to a nearby location or to a different location. Basically, you have the ability to use all these data centers or data lakes in multiple geographic locations, and you can use that power for your cloud applications, right? So the next one is elasticity. This is another one of the nice benefits of cloud computing in that your resources can scale up as you need them, generally automatically as well, right? If you have a, say, a phone application where it's network based, it's talking to Firebase or it's talking to MongoDB or some kind of a cloud resource, when you have 10 users, you don't need as many resources, right? But once you start getting, let's say, popular, hit the front page of the App Store, now you have thousands upon thousands of customers all using this thing at the same time. Your resources need to scale so that they don't get a denial of service error, right? They don't get that horrible resource not found because it's been taken down. With cloud resources, it will automatically scale upwards. And then if you start losing that user base, God forbid, it'll scale back down so you're not paying for as much. And that kind of ties in with the last point here, that cloud resources are a metered or a measured service where you pay for what you use. So if you have, 50 virtual machines, you're going to pay for 50 virtual machines. If you have a cloud resource that is being scaled up and down, you're only paying for what is being used, right? You're not paying like a bulk subscription fee where I have 500 virtual machine licenses and that's what I'm paying for. No, I will pay for what I've instantiated, and when I shut those down or disable them, I don't have to pay for it anymore. There are some caveats with persistent storage and with services that are, kind of separate from that, but basically you're only going to pay for what you're using, more or less. So that's kind of a high level of what cloud computing is, and this is not strictly, specific to Google Cloud. Take these concepts, apply them to AWS, to Microsoft Azure. Any of the cloud providers are going to have very, very similar characteristics. So take for that what you will. And now what we're going to be getting into next, we're going to talk about some of the costs of cloud computing. We'll be getting into some labs. So I hope you all have a wonderful class. And if you have any questions, any concerns, either contact me or watch that long Google Cloud video because it is really, really informative as to what is available out there. So thank you all. I'll see you later.